X-rays are high-frequency electromagnetic rays. The wavelength range is from 0.01 to 10 nanometers, with frequencies being in a range of 3.0 times 10 to the 16th power to 3.0 times 10 to the 19th power hertz. X-rays are about the size of an atom. X-rays are the highly strong rays which spread out when high-energy electrons strike a metal target. Later on, hospitals and other medical centers discovered that you could use the rays to see images of broken bones. X-rays are given off by stars and strongly by some types of nebula. Wilhelm Conrad Röntgen was a German scientist that first observed and documented about X-rays in 1895. He discovered that firing streams of X-rays through arms and hands created detailed images of the bones inside. When you get an X-ray taken, X-ray film is put on one side of your body and X-rays are shot through you. Bones are dense and absorb more X-rays than skin does. Because of that, shadows of the bones are on this X-ray film while the skin appears transparent. X-rays are used by doctors to see inside people to make sure they don't have any broken bones. X-rays are also used in airport checks to see inside of luggages to make sure there aren't any weapons in the luggage to assure safety to the public. They are also used by astronomers. Many objects in the universe emit X-rays which can detect using suitable radio telescopes. Many things in space emit X-rays. Among them are black holes, neutron stars, binary star systems, supernova remnants, stars, the sun, and even some comets. Form of ionizing radiation and as such can be dangerous. There is no threshold which radiation is considered totally safe. Even small doses of gamma and X-rays increase cancer risks, although by a small amount. Young women and teenagers who had many X-rays to monitor scoliosis have been found to be at increased risk for developing breast cancer later on in life. From identifying broken bones to disease, the X-ray is one of the most useful medical advancements in history. It is also the oldest and most common form of imaging.
When an electron beam strikes a block of copper, X-rays of frequency 2 times 10 to the 19th power hertz are produced. What is the wavelength of these X-rays? The formula we would use is constant equals wavelength times frequency. The constant is always 3 times 10 to the 8th power equals wavelength times 2 to the 19th power. We would divide times 10 to the 19th power. After this, you will get your answer for the wavelength of these X-rays. When the wavelength of an X-ray is 1 times 10 to the 26th power, what is the frequency? Frequency equals constant divided by wavelength. The constant, like I said, is 3 times 10 to the 8th power. And the wavelength in this problem is 1 times 10 to the 26th power. Once you plug this into the calculator, you will find your answer for wavelength.